All right, welcome back to the math show with Miss Condry. That might get old real fast, huh? All right, so remembering if you're doing this video on a different day than the one you did yesterday, here are our norms. Please be mindful of them as you're working at home. In this video, we're going to be talking about one of my favorite strategies that I've learned in the last couple of years. And it is ratio tables. Ratio tables are a model that we use a lot in actually starting in third grade, third, fourth, and fifth grade, and they get progressively more complex as we get older. And they're really leading into helping students understand ratios, which they're going to unpack more in seventh grade. So this is a really, or no, sixth grade. So this is a really great strategy that will help sixth grade, the transition to ratios, be hopefully a little bit simpler. You can find ratio tables in the Learning Packet 1 on page 117 and on page 69. This learning target is really all about modeling with mathematics. So in the parent video, I talked a little bit about how the approach that we're using to teach math is slightly different, or a lot different depending on your experience in math classes. But modeling with math is a really important thing that all mathematicians do. And a ratio table is a model that is going to help us, we can use it to solve problems that are fractions, decimals, multiplication and division of whole numbers or decimals or fractions. And it really helps us see the relationship between numbers, and that's a really important thing. So this model is really important and really fun once you get the hang of it. Okay, so ratio tables. Ratio tables are basically a model that is organizing numbers in a way where the ratio between the top number and the bottom number is always constant. So I like to think about this always in a context of some kind. Here I am going to use the context of jars of lemon drops because I think maybe a few fifth graders are craving some lemon drops, and don't worry, you're going to get your fair share of lemon drops when this is all over. So I am thinking about jars of lemon drops, and in this case I've got a jar, and in one jar will contain 15 lemon drops. Okay, so that relationship is constant. One jar has 15 lemon drops in it. Now, I can use what I know right here to help me figure out, well, how many lemon drops would be in 2 jars? How many lemon drops would be in 3 jars? 5, 10, and 50. The important thing about a ratio table is really you don't have to go in order, but you do have to understand the relationship between the numbers and maybe even model how you got that. So I'm going to just walk through this slowly, and if you want to pause before I give an answer to predict what I might do, that would be great. You can pause the video and predict, and hopefully you'll get better at it over time. So if I know that one jar has 15 lemon drops, I can use that actually to solve several problems up here. I'm going to go ahead and do 2 jars for the first part. So if one jar has 15, I'm picturing 2 jars that each have 15 in them. So 2 jars would hold double 15, which is 30. I can model what I just did there. The way I thought about it is that I doubled this one jar to get to 2 jars, which means I had to double the number of lemon drops. So I like to show that constant relationship using little arrows. This is going to get fairly messy because there's going to be a lot of different relationships I can use. All right, so now I can use that to solve other problems. I kind of want to go back to this one jar of 15 lemon drops, and I think I can use it actually to help me know 10 jars, because 1 10 times is 10, and that means that all I would need to do is multiply that 15 lemon drops in the one jar by 10 jars. And I have gotten pretty good at multiplying by 10, especially if I remember a place value work that we've been doing all year long. And when I multiply by 10, those digits are going to shift over one spot. So I'm left with 150 lemon drops in 10 jars. So right there I've shown the relationship here and here for the jars and the lemon drops, and I used something I knew already to help me figure this out. So now I'm going to go back to the 3 jars. 3 jars of lemon drops. So I already know that 2 jars holds 30 and 1 jar holds 15. So I could even just continue that skip count pattern and do 15, 30, and then the next one would be 15 more because there's 1 more jar up here. So I need 15 more lemon drops. 30 and 15 make 45. Okay. All right, now I see that the skip count pattern is stopping because it went 1, 2, 3, skipped 4, and now we're on to 5. So 5 jars of lemon drops. Ugh. Well, I could just add 15 and then add 15 more, or I could also notice that if I combined 2 jars with 3 jars, that would make 5 jars. And then I would just have to combine what's in the jars. 30 jars plus, or 30 lemon drops plus 45 lemon drops. So we've got 30 plus 45, and that is 75 lemon drops in 5 jars. Okay. I like to, when I'm adding something together, I like to show that relationship because I added 2 and 3 together, which meant that I had to add the lemon drops in 2 jars and 3 jars together. So I like to show that relationship by circling the things I added and using a little plus sign. Okay. Now the last one, 50. At first this might seem kind of daunting, but I'd challenge you to look for what numbers 50 is related to that we've already done. Hopefully you see that 50 is related to 5. And again, this is a times 10 relationship. So we've got 10 times 5 is, or 5 times 10 is 50. And that's awesome because that just means that I have to multiply the number of lemon drops in 5 jars by 10 to get how many lemon drops are in 50 jars. So if I multiply 75 times 10, again, everything shifts over. So the 7 is going to move to the hundreds place, the 5 to the tens place, and then there will be a 0 as a placeholder in the ones place. So in 50 jars, there are 750 lemon drops. I challenge you to make sure that when you're using ratio tables, you're actually looking for the relationships here to be a little bit more efficient. So use what you've already done. Make it as easy as you can for yourself. When you get really good at making it easy, you can solve seemingly challenging problems, including decimal multiplication and division problems, with very little effort on your part. So keep looking through your ratio tables and look for those relationships, and there's not one right way to go about it because there's so many different relationships. So do the best you can and show your work.